Hello all, welcome to my channel Codify with Sonal. Today we will be covering the part 5 of the AWS Solution Architect Associate Practice Series, and thank you very much for appreciating 4 parts of this series which are going great. And if you have not checked it out, please check it out. The links are in the description box below. So we'll be covering the real exam questions. So to tell you, these are not dumps. I have also been telling this in my previous videos. Please go through the services, go through its pros and cons, what is used, when, how it is used. Please go through all that and then come to the questions. Just certifying won't help. You should also know the basics, what service is used for what. So let's start. So we are doing question number 36. So 1 to 35 we have covered in our previous videos. Okay. So let's start. A popular social media website uses a CloudFront web distribution to serve their traffic, to serve their static contents to their millions of users around the globe. They are receiving number of complaints recently that their users take a lot of time to log into their website. There are also occasions when their users are getting HTTP 504 errors. You are instructed by your manager to significantly reduce the user's login time to further optimize the system. Which of the following options should you use together to set up a cost-effective solution that can improve your application's performance? So first of all, pause the video and go ahead and read the question twice to understand it properly. And see, here it is mentioned select two. Okay, so make sure you read in the question well. You have to select one answer or two answer. There's no negative marking. If you don't know, please mark and move ahead. Okay, so now what it is saying is there's a social media website. Okay, and it is using CloudFront web distribution with static content, static website, and they have users around the globe. Okay, and the users are in millions. So now they are receiving a number of complaints that users are taking lot of time to log into their website, and some users are also getting 504 errors. Okay, so you as a solution architect, you are being instructed by your manager that how will you reduce the login time to, like, you have to optimize it, right? You yourself as a user won't like if you are getting 504 errors in the uh, application or in the website, right? So what can we do to give a cost effective solution? Okay, and it should improve the performance also very well. Okay, so let's go read the options. Customize the content that the CloudFront web distribution delivers to your users using lambda at the rate edge, which allows your lambda functions to execute the authentication process in AWS locations closer to the users. So now, in the given scenario, you can use lambda at the rate edge to allow your lambda function to customize the content that CloudFront delivers and to execute the authentication process in AWS location closer to the users. So in with this, you can also add additional setup of origin failover by creating origin group. You can read more about it in the CloudFront documentation of Amazon Docs, AWS Docs basically. So if you use that origin specific, and you'll have it will automatic CloudFront will automatically switch to when primary origin fails, it will go to a secondary one. So this will not allow 504 errors what users are expecting. Okay, so the correct thing to this the correct answer to these question will be, you will have a lambda at the rate edge. Okay, because it will allow you to customize the content according to the AWS locations closer to the users. And then second thing, if you are setting up an origin failover by creating an origin group, so like that's what, if primary origin is not working, you can go to the secondary origin. Okay, and that's how you will avoid the HTTP status code failure error. So A and C are the correct answers, but why B, D, and E are not correct? Let's go and see that. Deploy your application to multiple AWS regions to accommodate your users around the world. Set up a Route 53 record with latency routing policy to route incoming traffic to the region that provides the best latency to the user. Now this is why this is incorrect. Okay, it will solve the performance issue. Okay, like but it will also give you a cost. You have to deploy your application to multiple AWS regions, and remember, whenever you're being asked cost effective, if the other option is correct, check out which is more cost effective option. Okay, every company wants to save cost, right? Now let's see why D is incorrect. Use multiple and geographically dispersed VPCs to various AWS regions. Then create a transit VPC to connect all of your resources. In order to handle the request faster, set up Lambda functions in each region using the AWS Serverless Application Model SAM service. Now, why this is incorrect? So it is because already, okay, fine, you can set multiple VPCs across various regions. Transit VPC is also okay, fine, valid, but it will still lot of setup, lot of maintenance cost effective option required. So best is to use Lambda at the rate edge. Okay. Next, configure your origin to add a cache control max age directive to your objects and specify the longest practical value for max age to increase the cache hit ratio of your app. CloudFront distribution is incorrect. Why? Because increasing the cache would definitely, cache max age size would definitely give you a better performance. But now here the problem is that they have in authentication process. Okay, so caching of the static objects is not a problem here. The problem here is login to their website, right? So it's an authentication based thing. So just increasing the cache control max age is not a valid solution. Okay. So as we discussed, Lambda at the rate edge and setting up an origin group is the correct answer. Next question. A company has developed public APIs hosted in Amazon EC2 instances behind an elastic load balancer. The APIs will be used by various clients from the respective on-premise data centers. A solution architect received a report that the web service clients can only access trusted IP addresses whitelisted on their firewalls. What should you do to accomplish above requirement? Now mark your keywords, as I always say: trusted IP addresses whitelisted and on firewalls. And now when they're talking about trusted IPs and everything, the thing what comes first thing that should come into picture is network load balancer. Okay, and you will have an elastic IP address, so you should trust EIP. Like you can bring your own IP, so bringing your own IP will have that you will use elastic IP address. And as I said, firewall, it will be network load balancer. So this way, there's no need to, re-establish the whitelisted new IP addresses. So the correct answer to this is associate an elastic IP address to a network load balancer. Okay, so let's see why others are not correct. Create an alliance record in Route 53 which maps to the DNS name of the load balancer is incorrect. Now, why it is incorrect? Because it won't allow them to access the application because of the trusted IP addresses on their firewalls. Okay, so you cannot even work that out. Associate an elastic IP address to an application load balancer. So as this is based on firewalls and IP addresses, so there's nothing to do with application load balancer. Okay, so that's incorrect. Create a CloudFront distribution whose origin points to the private IP addresses of your web servers. Now, why this is incorrect is because web service clients can only access trusted IP addresses. So, like the fastest way is to attach the elastic IP address. Okay. So EIP to network load balancer. Make this as a key point. Trusted IP address whitelisted. You see these four words? Definitely it is EIP and network load balancer, NLB. EIP, NLB. Remember this. A fast food company is using AWS to host their online ordering system, which uses an auto-scaling group of EC2 instances deployed across multiple AZs with an application load balancer in front. To better handle the incoming traffic from various digital devices, you are planning to implement a new routing system where requests which have a URL of so and so are forwarded to one specific target group named Android target group. Conversely, requests which have URL of so and so are forwarded to another separate group, iOS targeted group. So how your ordering system works, right, in Android and iOS. So that's how they are having two target groups. One is Android and one is iOS. So whenever the request comes from Android, it should be forwarded to Android target group, and so for the iOS. Okay, now how can you implement this change? Okay, so I hope the question is understood. So let's go ahead and understand what is correct and what is not correct. So as they have mentioned the correct URL, so you should use path conditions to define the rules. So there is something called as path conditions inside. We also call it as path based routing. Okay, so what it does is it helps you to define rules, that forwards requests to different target groups based on the URL. So the definition itself is there in the question, guys. Target group based on the URL. This is what path based routing. Okay, so why others are not correct, let's go and check that. Use host conditions to define rules that forward requests to different target groups based on the host name in the host header. This enables you to support multiple domains using a single load balancer. Now, why this is incorrect? Because host-based routing defines rules that forwards requests to different target groups based on the host name. We have been asked for the URL, not on by the host name. Replace your ALB with a network load balancer and then use host conditions to define rules that forward requests to different target groups based on the URL in the request. Now, why this is incorrect is because network load balancer is used for applications that need extreme network performance and it uses static IP. Okay, so it will not support path-based routing. Replace your ALB with a gateway load balancer and then use path conditions to define rules that forward requests to different target groups based on the URL in the request. Now, why this is incorrect is because gateway load balancer itself does not support path-based routing. You must use an application load balancer to do that. So, the correct answer we have seen, it is path conditions to define rules that forward requests to different target groups based on the URL in the request. Next question. An application hosted in EC2 consumes messages from an SQS queue and is integrated with SNS to send out an email to you once the process is complete. The operations team received 5 orders, but after a few hours, they saw 20 email notifications in their inbox. Which of the following could be possible for culprit for this issue? So now what they are saying is they are using SQSQ integrated with SNS, which consumes EC2 messages. Okay, now it will send out to you email only once the process is completed. Okay, so now what is happening is after receiving 5 orders, they should get 5 emails, but they saw they are getting 20 emails. Okay, so what does this mean? Why it is happening and who is the responsible for this? So I'll tell you one thing about SQS first, that SQS will continue to exist even after the EC2 instance has processed it until you delete the message explicitly. Okay, you have to ensure that you delete the message after processing, so that to prevent message from being received and processed once again, because till the visibility timeout expires it will keep processing. So the three main parts in distributed messaging system are what? EC2 instances, SQS servers, and messages in the queue. So the correct answer to this is the web application is not deleting the messages in the SQS queue after it has processed them. But we'll see why A, B, and D are not correct. So web application does not have permission to consume messages in the SQS. Now, why this is incorrect is because not having a correct permission would have resulted into a different response. It will not over send the messages, correct? And whereas concern for the web application is set to short polling, so some messages are not being picked up. So this can also not be correct because you are receiving messages which are certainly being processed. You are receiving like more than once, right? It won't result into 20 messages. It's the same logic. Last one for the web application is set for long polling, so the messages are being sent twice. And now, why this is incorrect? Because long polling helps in reducing the cost of using SQS by eliminating the number of empty responses. When there are no messages available for a receive message request, like it will basically stop you from sending empty messages. Okay, messages being sent twice is not long polling. So correct is you're not get the messages are not getting deleted. Next, a solution architect needs to set up the required compute resources for the application which have workloads that require high sequential read and write access to very large data sets on local storage. Which of the following instance type is the most suitable one to use in this scenario? So coming to this question, this type of question will definitely be there. At least one question will come out of 65 questions. So make sure you study all these instances carefully. At least study their key points. Okay. So now the keywords here are high sequential read and write. Okay, and it is very large data sets, local storage. Okay, local storage. Make that in point. Okay, as I told you, the keywords, right? So storage optimized instances are designed for the workloads that require high sequential read and write access to very large data sets on local storage. Okay, so this is the definition of storage optimized instances. So basically you need to know the proper definitions, proper understanding of the services. What the question is, it is a definition of the answer. Okay, we have seen this right in the previous questions also. So now, storage optimized instances, they are optimized to deliver tens of thousands of low latency random IO operations per second to the application. Okay, so why memory optimized is incorrect is because memory optimized are designed to deliver fast performance for workloads that process large data sets in memory, not on local storage. Okay. Then compute optimized is because compute optimized is incorrect because it is ideal for compute bound applications that benefit from high performance processors. Okay, such as batch processing is required. No, that time you should go for compute optimized batch processing workloads, or media transcoding. Then general purpose instance. General purpose instance is the kind of basic type of instance. Now here they need high sequential read and write access, large data sets. Okay, so for the that general purpose won't be suitable. So the correct answer to this is storage optimized. Okay, an application is hosted in an auto-scaling group of EC2 instances. To improve the monitoring process, you have to configure the current capacity to increase or decrease based on a set of scaling adjustments. Based on a set of scaling adjustments. Keywords. This should be done by specifying the scaling matrix and threshold values for the CloudWatch alarms that trigger the scaling process. Which of the following is the most suitable type of scaling policy that you should use? Definitely one question from the scaling policy. Okay, so now make sure you know all the scaling policies, what are its matrix. One of the very famous question is, I don't know I don't remember whether I've covered that. What kind of metric is not a custom metric in scaling policy? Okay, that kind of question, if I remember that question or I get that question somewhere, I'll definitely put it up in the community post. Okay, So let's go with this. We'll read whatever, we'll check out what each scaling means, okay, and what is the correct to this one. So now let's go ahead and see all the scaling one by one. Step scaling. So what is step scaling is increase or decrease the current capacity of the group based on a set of scaling adjustments. It's a group of scaling adjustment and that vary based on the size of the alarm breach. Okay. Then scheduled scaling. How does scheduled scaling work is, it is based on a schedule, right? As the word says, it allows you to set your own scaling schedule. Like if you know that after maybe in the night I have my workload as very less, so according to that the scaling policy will be working, okay. It will decrease the resources so that unnecessary usage is not done, okay. So that's how it works. Like that is suitable when you have a predictable load changes, okay. And whenever you're using dynamic scaling, this is not considered, okay. And here in this scenario the correct answer would be a step scaling. Why? Because as I said, it is a set of scaling adjustments and it is done on the breach of CloudWatch alarm. So the correct answer to this is step scaling. Why simple scaling and target scaling is not correct is because simple scaling is not based on a group of scaling adjustments. It is just based on a single scaling adjustment. And target tracking scaling is based on target value. Like if you have achieved that kind of that kind of metric value, then only it will increase or decrease your resource, okay. So this is a very simple and straightforward question. Set of scaling adjustments, so the correct answer is step scaling. Next question. A solution architect needs to deploy a mobile application that collects votes for a singing competition. Millions of users from around the world will submit votes using their mobile phones. These votes must be collected and stored in a highly scalable and highly available database, which will be queried for real-time ranking. The database is expected to undergo frequent schema changes. Real-time ranking, frequent schema changes throughout the voting period. I've already highlighted you the keywords. Okay. Which of the following combination of services should the architect use to meet this requirement? So first of all, we have already seen frequent schema changes is what? DynamoDB, right? So when you see this frequent schema changes, what should come into your mind? DynamoDB. Okay, so here we have it in only one option. So yeah, this is the correct option. We'll discuss why and why others are not correct. So DynamoDB is what exactly? It is a durable, scalable and highly available data store which can be used, okay, in real-time tabulation. You can also use AppSync with DynamoDB. Okay, it will make it easier to build and collaborative apps. What is AppSync? It syncs the whole application and keeps you up to date, okay. You just specify the data for your app with simple code statements, and AppSync manages everything to keep your data updated in real time. Okay. So why DocumentDB and AppFlow are incorrect? DocumentDB is a viable database option. Okay. AppFlow cannot interface with it query updates. So why RDS is not correct, you know it, and why Aurora and Cognito is not correct is because relational database solutions like Aurora is also relational database. Okay, they are impractical for your frequently changing schema, and Cognito is just for user authentication and authorization. Okay, so nothing as such is mentioned in the scenario. So the correct answer is DynamoDB and AppSync. Next question. A company is running a multi-tier web application farm in a virtual private cloud, that's VPC, that is not connected to their corporate network. They are connecting to the VPC over the internet to manage a fleet of EC2 instances running in both the public and private subnets. The solution architect has added a Bastion host with Microsoft Remote Desktop Protocol access to the application instance security groups, but the company wants to further limit administrative access to all the instances in the VPC. Which of the following Bastion host deployment options will meet this requirement? So first of all here, what is a Bastion host? So Bastion host is a special purpose computer on your network specifically designed and configured to withstand attacks. Like if you have a Bastion host in AWS, it is basically just an EC2 instance. Okay. So what it does is it is in public subnet, and then either you can have a public IP address or a elastic IP address, and with sufficient of RDP or SSH access defined in the security group. Now users log on to Bastion host via SSH or RDP and then use the session to manage other hosts in the private subnets. Okay, I hope now that is clear. So let's go with the options one by one. Deploy a Windows Bastion host with an elastic IP address in the public subnet and allow SSH access to the Bastion from anywhere. So now why this is incorrect is because uh, since it is a Windows Bastion, okay, you should allow RDP, not SSH. Okay, so this is clearly out of question. Coming to next, deploy a Windows Bastion host with an elastic IP address in the private subnet. You do not deploy Bastion host for private subnet. Okay, so that is incorrect basically. Okay, it should always be deployed in the public subnet, not private subnet. Deploy a Windows Bastion host on the corporate network that has RDP access to all EC2 instances in the VPC. So now this is also incorrect because you do not deploy Bastion host to your corporate network. It should be in the public. It should be in the public subnet of your VPC. So deploy a Windows Bastion host with an elastic IP address in the public subnet, correct, and allow RDP access to Bastion from the corporate IP, only from the corporate IP addresses. So this is the correct answer. That what happens is you will deploy the Bastion host in public subnet with an elastic IP address, and as it is a Windows Bastion host, you will allow RDP access only from your corporate IP addresses. Clear? Next question, an AI powered forex trading application consumes thousands of data assets to train its machine learning model. The application's workload requires a high performance parallel hot storage to process the training datasets concurrently. It also needs cost effectively cold storage to archive those datasets that yield low profit. Which of the following Amazon storage services should the developer use? So now here, first of all, you should understand what is parallel hot storage and what is cold storage. Cold storage means it is archived, you need whenever you need, it should be available at a certain amount of time. Okay. So according to this question, it needs two requirements. It wants high performance parallel hot storage, okay, and cost effective cold storage. So in this case, what we can do is we can use FSX Lustre for the first requirement, that is the high performance parallel hot storage, because to process data sets concurrently. Okay, and for the second one, we can use second requirement, that is the cold storage. We can use S3 because it is the most cost effective. It has glacier deep archive. Through that, you can use that. Okay, and why FSX Lustre? We have already discussed Lustre previously also. So FSX Lustre is a high performance file system. It is used for fast processing of workloads, and it is a particular open source parallel file system which stores data across multiple network file servers to maximize performance and reduce bottlenecks. Now let's see why others are not correct. That is A, B and D are not correct. So let's read that. Use FSX for Windows file server and S3 for hot and cold storage. So now why Windows file server should not be used is because Windows file server does not have a parallel file system itself. Okay, Lustre has that, not Windows file server. Okay, so this is incorrect. Then next, use elastic file system EFS and S3 for hot and cold storage respectively. So now EFS supports concurrent access, but it does not have that kind of high performance ability that you require at machine learning levels. So D, use FSX for Lustre and EBS for provision IOPS SSD. volumes for hot and cold storage. So hot storage is correct here, but for the cold storage they are using EBS. So EBS has an option called as HDD, but its price is very high and it is idle. It is not ideal for data archiving. So cold HDD is like much more expensive than S3 Glacier or Deep Archive, and here we need a cost effective one. Okay, read this. As I told in some previous question also, that whenever it is cost effective, make your choices correctly. Okay, so the correct answer to this is use FSX for Lustre as a hot storage and for cold storage S3. Okay. Coming to the next question, a game development company operates virtual reality and augmented reality games which use various RESTful web APIs hosted on their on-premises data center. Due to the unprecedented growth of the company, they decided to migrate their system to AWS cloud to scale their resources as well as to minimize their cost. That is the reason of AWS, right? Which of the following should you recommend as the most cost effective and scalable solution to meet the above requirement? Okay, they have there's a gaming company which works in AR and VR. Okay, they have RESTful web APIs developed on their hosted on their on-premises data center, and now their company is growing and they want to move to cloud. Okay, moving cloud reasons we have discussed a lot of times in the cloud practitioner series, so you can check that out if not checked. Okay, so what is the most cost effective? The point here is most cost effective and scalable solution. Okay, and as this is a REST API, you need to think about that also. So the best answer in this scenario should be a combination of Lambda and API gateway, because this solution is best cost effective wise also, and also it is highly scalable. You will be charged only when you use your Lambda function, unlike having an EC2 instance that will always run. So the best way is to use Lambda and Amazon API gateway. Now let's see why other options are not correct. Use a spot fleet of EC2 instances, each with an EFA, that is Elastic Fabric Adapter. Now, what is Elastic Fabric Adapter? It is like a simple network service that you can attach to your EC2 instance. It is as simple as in computers how you have your graphic cards, right? Something related to that kind. It provides you HPC cluster. You have a lot of flexibility, elasticity, scalability provided by the cloud. Okay, but EFA is scalable here, but spot fleet of EC2 instances is not a scalable option here. Okay, it doesn't have auto scaling involved, so that this is the reason why this answer is incorrect. Set up a microservice architecture with ECS, ECR and Fargate. Now ECS is mainly used to host Docker applications. Okay, and in addition with ECS and ECR, Fargate alone is not scalable. So that is why this is not recommended in this scenario. Last option, host the APIs in a static S3 web hosting bucket behind a CloudFront web distribution. Now, why this is incorrect is because there is no compute capability for S3. Okay, you can use it as a static website, although this solution is scalable since it is using CloudFront, right? So, but the use of S3 to host web APIs or dynamic website is still incorrect. So correct answer is Lambda and API gateway. So here we come to the end of this practice series. Let me know if you have any doubts. Please put a comment below. And how did you like the questions, and what topics you're feeling that it is quite difficult to understand? Please let me know. I would create a detailed video on that. Do check out the Amazon AWS hands-on labs which I am doing. And if you want any particular topic, a hands-on demonstration, please let me know. Till then, stay happy. Let's codify with Sonal in the next video. Please like, share and subscribe my channel. Do not forget to hit the bell icon to get a notification of the updated video. Thank you.